Here we're looking at two glass slides clamped together with a clothes peg and a fountain pen. I'm doing some experiments to see if I can measure the pressure of the ink at the tip of the fountain pen. And here we go. The fountain pen's getting into contact between one piece of glass and the other, and the ink is drawing itself into the narrow gap by capillary action. Where it goes. Spreading nicely. This is not a uniform width gap. The purpose of the clothes peg is to bend the glass slides. They're almost touching at the middle, and towards the top of the picture and towards the bottom they get further apart. The ink's spreading nicely. It seems to have stopped. I'm just checking. Yep. Go on, go on. A bit more ink. No. Here the gap is larger. Try and get some ink in there. Doesn't want to go. I think it might in a moment. There it goes. Now what's happening here? The ink is at a pressure in the nib of the pen that's slightly below atmospheric pressure. If it's going to escape from the pen, like it's doing now, into the narrow gap between the glass slides, the ink has to pull itself out. And it can do that because the ink is in a very narrow slit gap, in a narrow gap between the two glass slides. So the ink is able to pull itself out. As the ink spreads further and further though, it gets into a region where the gap between the two slides is too large. The pressure of the meniscus of the ink pulling the ink further and further out reduces as the gap gets larger between the two glass slides. So eventually you reach a point where the meniscus pulling the ink out has just provided just enough force to balance the let's call it negative pressure, to balance the negative pressure inside the pen nib, and movement ceases. So the position of this blob of ink, if I knew how wide the gap was at the point it stops, I would be able to calculate the negative pressure at the pen nib. Well, here we go. Here's my notebook from earlier on in the day, showing my plans for making the equipment, and here is a tracing of the test rig, and I've put a feeler gauge into the gap between the two slides and plotted where the different gap thicknesses are. And now our test subject placed on top. Oh, that's rather nice. It looks as if the ink has moved out to around 0.15. That's a contour line of the gap between the two slides. Yeah, on the left hand side. Let's check the right hand side. Yeah, the numbers are increasing to the right, and that's about 0.15. So in this pen the ink spreads out until it reaches a gap of 0.15 millimeters, and then it stops. From that information we can theoretically work out what the negative pressure is at the tip. You can see the slight arc of the glass slides here, caused by that clothes peg. The ink is quite stable in there. Give it a good bash. Doesn't move around, doesn't fall out. Yep, still matching the 0.15 millimetre line. Where's the pen that was performing? There you go. There's the pen. Good job.